Hi, my name is Ying and thanks for watching. So this video is a recorded version of the public presentation that I did for my thesis defense, and I thought that this video would be great to make because not only would it help me get my research out there, but you can also see how I managed to fit 3 chapters worth of research done over 2 years into one presentation. So my thesis was titled Messy Mangroves, Anthropogenic Marine Debris in Mangroves Globally, with an investigation on Hong Kong mangrove debris and its effect on the faunal community. My outline for my presentation is that I had 3 sections. So I did a literature review for my first chapter where I was trying to understand what's already known about mangrove marine debris. And my second chapter was looking at how much marine debris was in Hong Kong mangroves. And then my third chapter was an experiment trying to see what the potential impacts of marine debris might be on mangrove fauna. So what are mangroves? Well, mangroves are trees that grow in the coastal intertidal zone near rivers, and they also form the mangrove habitat. So the term mangrove can refer to both the tree and the habitat. The trees possess many adaptations to living in this salty, harsh environment, and 2 of them are aerial roots and vivipary. So these aerial roots, this kind is known as a pneumatophore, is where the root grows up out of the soil to kind of exchange oxygen with the air directly, and the other adaptation is vivipary, which is pretty much live birth. So the seed germinates on the tree and it gives the baby mangrove an extra boost of energy. And so eventually the baby seedling, known as a propagule, drops off the tree, and it will be carried around by tidal action so that it can find a new place to settle and grow into an adult. And mangroves are also incredibly diverse and important habitats for many species. So here in Hong Kong there's a few important ones, including crabs, eels, snails, horseshoe crabs, mud skippers, fish, you name it. They're very diverse habitats. But mangrove trees themselves are also quite diverse. So there's more than 40 species spread out across the world, and you can see that they're spread mostly around the equator, with the peak of diversity in Asia. So why would I study plastic pollution in mangroves? Well, awareness of plastic pollution is at an all-time high, and we're all very concerned about, how many plastic bags we're using, how many straws we're using, and that's even more apparent now. So we're also using, if we're ordering a lot more takeout, we're wearing more disposable masks, wearing disposable gloves. So I think it's important to understand where plastic ends up so we can address its impacts, but also, more importantly, address where it's coming from. So what we do know about where plastic comes from is that it can, marine plastic. So we know that it can actually end up in the ocean through rivers. So rubbish that's mismanaged in upstream sources during rainfall events can be eventually washed out into the ocean via the rivers. So this graph shows us some of the rivers where there's a lot of plastic entering the ocean. And you can see the hotspots also are the same hotspots of mangrove diversity. So the top of the top 20 rivers that are polluting into the ocean, 16 of those rivers are actually associated with mangroves. So the relationship between an overlap between where plastic pollution hotspots are and the peak of mangrove diversity overlap is very interesting, and there's very little research done on this relationship. So that really goes into my first chapter, where I tried to explore what existing studies had been done. So what we do know is that coastal debris studies date back to the 1970s, and 95% of those studies were actually done on beaches, even though beaches comprise only like 30% of ice-free shorelines around the world. And of the remaining 5% of studies, they encompass all other coastal habitats, so including not only mangroves, but salt marshes and rocky shores and other kinds of shorelines. So mangroves are really underrepresented in terms of coastal marine debris studies, or you could probably say beaches are overrepresented. But I definitely think we just need more research in general. So when looking at the past existing studies, what I found is that there were only 12 studies that really quantified debris in a mangrove. And the first one was done in 1996, so that's like more than, nearly 30 years after the first beach debris study. And then after that study, there was like a 15-year gap between that and the next one. So that's a very interesting pattern. And of existing studies, a majority of them were done in Central and South America, and very few have been done in Asia, where our peak of plastic pollution and mangrove diversity overlap. So that really tells us more about the types of research groups that are pursuing anthropogenic marine debris research. And so in mangroves specifically. So what they found is that a majority of debris was plastic, followed by wood. So that's not really that surprising, because plastic can be found across every habitat. But wood is interesting because there's a lot of fisheries near mangroves because of how they support so much diversity. So these fisheries, as well as the settlements that live near mangroves, may actually be contributing a lot of marine debris to the mangroves. And what these studies found is that debris density, so in terms of items per meter squared, really varies. So some studies found less than 1 item per meter squared, which means that mangrove is practically pristine, and other studies found more than 25 items per meter squared, which really indicates that it could be quite polluted. And results between studies were quite hard to compare because there were no standardized methods. Everybody was using slightly different methods of measuring and comparing debris. So one study was, some studies were saying, anything bigger than 2 millimeters is a macroplastic, anything bigger than 5 millimeters, and some were saying more than 2.5 centimeters. So those gaps in terms of classifying debris really affects your readings for items per meter squared. But from these studies, there were some similarities in terms of how plastic interacts and impacts marine forests. So one of those, some of those studies tended to find that because mangroves are quite dense, complex habitats. So if you have a higher tree density, you had a higher density of debris. And if you had a lower tree density, then you had a lower density of debris. So those high density forests were like trapping and keeping the rubbish there. And those aerial roots that I was talking about earlier that help mangroves exchange oxygen, well, they might be acting as a mesh and a filter by trapping larger debris or letting smaller debris through. And in addition to that, there's here on these nematophores, there's a lot of oysters encrusting and growing on them, and that provides additional places where rubbish can be caught in terms of being trapped by the nematophores, so that like plastic bags. And additionally, other mangrove fauna, such as crabs, have been seen interacting with plastic, like dragging it around, and crab burrows are also it may act as like a trap for plastics by getting trapped inside the burrow. So mangroves are also impacted by marine debris from both the landward and seaward sides. So those rivers, they bring rubbish into the mangroves from upstream sources, but there are also people who live near mangroves who might be contributing some amount of debris to the mangrove. You can see in this aerial photo, this is a terrestrial aquaculture pond, and some of the rubbish might actually be coming from those ponds. And what we do know, and also because they're coastal habitats, they're also exposed to rubbish from seaward sources, so rubbish that's in the ocean coming into the mangrove. And so once debris is in the mangrove and it ends up at the landward side or starts at the landward side, it's just unlikely to disperse all the way out to the ocean. So these are very, so for these reasons, there's a lot we need to understand about how mangroves actually might be acting as a trap. So what are the actual risks and impacts to the mangroves themselves caused by marine debris? Well, mangrove seedlings and aerial roots may actually be damaged and smothered by debris. So as it moves around, it might be crushing some of these trees. And it's been shown that damage caused by bamboo poles can actually cause mortality in some is correlated with crown dieback in some mangroves. So they might actually be contributing to some mangroves dying. And Excessive debris also reduces the places where seedlings can settle. So when I was talking about those propagules, well, they're going to float around trying to find a place to germinate and become an adult tree. But when you're if it's blocked by marine debris, it'll really affect the ability of a mangrove forest to recover. And so because of that, and also excessive debris can also reduce the places for surface sediment feeding organisms like crabs and snails. And because there's so much rubbish there, that rubbish can break down into microplastics, and again, those crabs and snails are at risk of ingesting it. And what we found is, we've done these surveys in Hong Kong, that some of these Hong Kong mangrove crabs do have plastics in their bodies, so they have been already, eating this plastic. And so I think understanding the area covered by debris is really important in terms of trying to understand the potential impacts caused by plastic pollution. So for future studies, what I really like to see is that there's just more studies trying to understand how much rubbish is in mangroves just across the world, and also just the impact of what this plastic pollution might be on mangroves in general. I think we need to move towards a standardized methods for understanding mangrove and understanding how much debris is actually in a mangrove. So more standardized more standardized methods for quantifying debris. For instance, agreeing that maybe using 5 millimeters size is the minimum threshold for macrodebris might be a good place to start. And quantifying debris in terms of percentage area covered might actually be more ecologically meaningful than just counting debris. So I think overall, I just want to see more research being done, because 12 was just too little and was incredibly surprising. So going on from that, I decided to do my own survey across Hong Kong mangroves. So Hong Kong is located at the mouth of the Pearl River Delta, and we're located in this Pearl River Delta. There's a number of mega cities such as Guangzhou and Shenzhen that are located right along the river, and this delta, and into this delta, 3 of those top 20 plastic polluting rivers actually converge. So this is a good place to study plastic pollution. And even though Hong Kong is so small and we're really thought of like as a concrete jungle, there's more than 50 mangrove stands across Hong Kong that cover more than 500 hectares. And we do have a decent diversity in terms of our mangroves. We have a good number of mangrove tree species and mangrove crabs and snails. So for my project, for this chapter, I had 2 main questions that I wanted to answer. So how much rubbish is there actually in Hong Kong mangroves? And the other question was, is there a significant difference in debris between the landward and seaward zone of the mangrove? Because, previous studies suggest that mangroves are acting as a trap, and maybe it's being trapped at the back of the mangrove. So that's what I wanted to look at. And I also wanted to kind of figure out what the potential sources of debris are, especially between those different zones. So I went to 18 different sites across Hong Kong. I excluded certain sites that were too small or even artificially dammed. So there were some sites that were, if they're dammed, they're not going to be exposed to water from the sea, so I wasn't interested in going to those sites. And I did this fieldwork between May and October of 2018. So I'll just start with my first section. So I wanted to, in terms of quantifying debris, it was difficult because there's no standardized methods. So I designed this method based on a number of studies and my own trial and error to see what was most effective. So I did belt transects at the landward and seaward zone of the mangrove, and I identified rubbish according to its type and use. So type is really kind of self-explanatory. If it was a piece of plastic, it was plastic. And I also had a biodegradable category. So things, even though they might have an organic origin, they still take a long time to degrade. But so I decided to just put them under biodegradable, even though they would still have a significant impact. And in addition to that, every item was given a use category, which was a proxy for the origin of debris. So if I found, say, an aluminium can, I put it under metal, and then it would be a food item. So each item got 2 categories assigned to it. And in addition to counting debris, I also measured it for its footprint to see how much space it was taking up on the surface of the sediment. So as you can see, these two pieces of rubbish are very different sizes, so their impact would therefore be very different on the mangroves. So I think that was an important measurement to take. So what were my results? Well, unsurprisingly, I found that more than 80% of rubbish was actually plastic, and that is completely consistent with every other coastal debris study, so I was not surprised. But by composition, but by area covered, well, those biodegradable objects just shot right up in terms of the amount of rubbish, the composition it made up in the rubbish. So that's not surprising at all, because when you think about the wooden types of wooden rubbish I was finding planks of wood and big, huge bamboo poles. So they're taking up much more space. And debris that fragments easily, such as plastic or glass, would be completely biased in my accounts. So sometimes I would come across a glass bottle on the ground, but it had been smashed into like 20 different pieces by like wave action. So you can see that it was one object, but in the counts it would be 20 pieces. And so from these results, I think what we can see is that even though wood might be biodegradable, and it can still have a significant impact in terms of what it might be doing, how it might be affecting the mangrove, especially if the impacts are, smothering or reduced surface area for where seedlings can settle. So what did I find in terms of actual numbers of how much debris is in the mangroves? Well, I think, I'll talk about my landwood and seawood side differences later, but in terms of average items per metre squared, well, it was 1.5, and in terms of average area covered, it was about 6%. So you can see that when we go back to the previous studies that have been performed, well, Hong Kong is at the cleaner end of the amount of rubbish that can be found in our mangroves. Except I wouldn't say that that's a complete good news story. It's still a problem in Hong Kong mangroves, and I think there are definitely sites where we can address our issue of plastic pollution. These numbers are just averages. So as I said, they're just averages. So when we look at Hong Kong mangroves across the region, you can see it varies quite a lot. So here I decided to use just the landwood data because the seawood data was quite small, small in number. And as you can see, like there were some sites where there was about like a 30% average coverage by debris. And trying to understand how these different sites were impacted by debris, well, an easy driver might be the presence of the Pearl River Delta. So I decided to check if there was a significant difference in sites on the west coast and on the east coast. And what I found was that no, the Pearl River Delta didn't seem to have an effect, or at least sites on the east and west coast were not significantly different. So I think even though the Pearl River Delta is so big, like Hong Kong, the mangroves tend to grow in sheltered areas that might not be as impacted by wave action from the Pearl River Delta. And also Hong Kong's just like a small region, so maybe it's just not that affected. So what are the drivers of debris across these different sites? So looking at all these different sites, well, how come some sites had more than others? Well, another thing I wanted to look at was looking at their sources of debris. And I didn't really see a pattern in terms of which sites had more rubbish from where. It was just all over the place, which I think is a reflection of, that it all just gets mixed up. So there's no one source. You can't just say, oh, it's all the fishing industry's fault. I don't think that's necessary. That it's a big contributor, but I think that industrial sources such as construction waste or commercial items, maybe factory warehouse dumping was also happening. So the only pattern I guess we could talk about maybe is that these three sites are located in Deep Bay. So Deep Bay, so Shenzhen is actually, mainland China is actually up here, and Shenzhen is right there, and between these two cities there's Deep Bay, which has a number of aquaculture farms, so I think growing oysters. So there's a lot of, so that impact and influence might be driving the higher levels of fishing debris in those mangroves, but I think that that probably needs more investigation. So overall, there's no single possible origin that was overrepresented across Hong Kong mangroves, and trying to understand, trying to address these problems is clearly something that's multifaceted, and you can't just say, okay, target this source. I think it needs to be a more broader scale effect. So another thing I wanted to do was see if there's a significant difference in debris between the landward and seaward side of the mangrove. So yeah, what I did find was there was about 5 times more debris at the landward side compared to the seaward side. So that was significantly different and a very interesting result. So as I alluded to before when I was in that little table, yes, there's a lot more rubbish at the landward side. And so when we're trying to think about possible sources, like maybe is there more dumping by domestic users at the landward side, and maybe is there more fishing debris at the seaward side? So, but when I looked into the data, actually, this actually wasn't true. So it didn't come out in the data to show that the domestic rubbish actually made up a higher proportion at the landward side. It was just very similar on both sides. So I think that's interesting because that just shows, I think what's happening is that perhaps there's some equalization of rubbish at the landward side. So when there's a high tide event, all the rubbish just gets pushed to the back of the mangrove. So even we have a lot of typhoons in Hong Kong, so maybe these big events are pushing all the rubbish to the back, and it all just gets mixed up. And also, there's also an effect of like why there might be more debris at the landward side is because, as previous research suggests, it just doesn't end up coming back out, dispersing to the ocean at all. And I think at the seaward side there was a lot of movement of debris, because I would go to some sites and you could see that some rubbish is moving in and out of the front section of the mangrove, but once it gets to the back it just doesn't have a chance, it's stuck there. So thinking about this, it made me really want to understand what the potential impacts of this long-term marine debris might be. So I looked, when I was out in the field, these are some of the sites I was greeted with. So there are some sites with huge coverage by marine debris. And what this means is that I was like, okay, some of this rubbish has been here for years. What could the impacts be on the fauna that live here? And when I looked at past studies, well, what I found is that most existing studies focus on the effects of marine debris at the individual level. So we're talking rates of ingestion of microplastics on crabs, or entanglement by plastic debris, or those kinds of studies. So trying to look at higher levels, like the population level, a lot of the studies were looking at how marine debris might disperse non-native species, like the little larvae are, using it as a raft or other purposes and floating to other places, or maybe it's even passing pathogens around in a coral reef. So it wasn't really looking at how communities might be different because of the presence of marine debris. And mostly, and if it was, it'd be looking at invasive species. So I wanted to know, how does the physical presence of marine debris affect the fauna? So the presence of marine debris changes the habitat complexity. So when you add a piece of rubbish there, you're just changing how complex the habitat is. And what we do know is that habitat complexity is linked to species diversity. So and this is also linked to abundance and composition. So additional habitat complexity caused by new objects to create more niches for things to live in and to grow on, that is how it affects species diversity. So little research is done on how marine debris is actually affected by community assemblage, but we do know that mangrove fauna does grow on debris, or this little crab is hiding from me in the debris. It's just temporary, but a survey found that there were like shrimp, mussels, crabs, snails, all using marine debris as some form of habitat in a previous survey. And so what I wanted to know is, can the presence of anthropogenic marine debris cause a shift in the community assemblage? So I decided to do my experiment in 3 Fathoms Cove in Hong Kong. So this is a site that I had been to for my previous surveys, I decided to set 20 quadrats, so half of which had 0% coverage and the other half had 25% coverage of debris, and that's my experimental number. I decided to, experimental quadrats, I decided to use 25% because I thought, it's an easy amount for me to gauge in the field. A quarter of my quadrat was covered in debris, which I would spread out over the quadrat. And I thought it'd be like a realistic high number of debris for mangroves in Hong Kong, because our average was only 6%, but at landward sites we had up to an average of 13% coverage, and also like some sites had up over 30%. So I was like 25%, that's a good number. And I set this experiment for about 3 months with monthly checks on, just to make sure that the debris wasn't floating away or something. Just to see what was, maintain my quadrats. So these are the rough locations for my quadrats. They weren't touching each other, that's just how it looks on Google Earth. But you can see that they're all just like in one space, which is also why I chose this site, because there was a decent amount of space for me to do my experiment. So does a 25% increase in debris coverage cause a shift in community? That's what I wanted to know. So to do that, I needed to do a fauna survey at the beginning and end of the experiment. So I surveyed my crabs and snails, with the help of my lab, really. They were pivotal for me to finish this experiment. So they were really helpful. We used methods derived from SCOVET et al. And that we've been using across Hong Kong. And to make sure that there was as little confounding variables caused by environmental conditions, I tried to make sure that there were similar conditions on each day. So similar temperature, similar humidities, and similar cloud coverage. As crabs are known to be quite, temperamental, maybe. Like if it's really sunny, they'll be out and about and eating and feeding. And if it's cloudy, they might not be as active. So I wanted to make sure that those variables were reduced. So what did I find? Well, my crab abundance, so my number of crabs between the 2 days, were not significantly different between treatments. So that was a bit disappointing. And then I decided I wanted to look at assemblage, so the types of species that were there. And this graph is an NMDS graph. So if they were, what you want is the shapes to be quite separated, like the clear and the solid shapes. But what we found is that they're quite gathered, which indicates that their assemblages are very similar on each day. So there was no effect on numbers of crabs or species composition of crabs on between each treatment and each day. And how about my snails? Well, again, you can see from this map, this graph, it's quite similar. So there was no effect on treatment on gastropod abundance. And when I was trying to look at gastropod assemblage, I also found that they were quite similar. So again, the graph was not separated, so there was, again, no effective treatment on gastropod assemblage. So I found that there was no effective treatment, but actually what I did see was there was a significant difference between the dates. So I had tried my best to make sure that the environmental conditions were as similar as possible between each day. But when we're thinking about crab activity, then maybe I started my experiment a bit too early, before crabs are as active as they normally would be, or maybe it should have been a bit longer. So that's probably what happened there. And I think the reason why there wasn't a significant effect again on treatment was that mangroves are pretty complex habitats anyway. So I think for future research, what needs to be done is there needs to be an assessment on habitat complexity before you begin your survey, to really see how much rubbish needs to be added to actually cause a significant effect on habitat complexity. So this study was very preliminary, but I think it still gives some interesting results to understand what effects might be. So maybe 25% coverage wasn't sufficient. Maybe you want a higher level. Some previous studies have shown that in snails, their feeding behavior doesn't change until you increase feeding debris coverage to 50%. So maybe that's what's needed. And again, maybe a longer experimental period or a different experimental period may also make a more robust study. So what are my take-home messages from my research? Well, I think for sure mangroves are understudied in coastal debris research overall, so we can really do more research there. And because of that, they've been overlooked as traps for marine debris. And aside from plastic, wooden waste is also a concern that we should think about, especially since mangroves are so close to settlements that use wood as a biodegradable construction source. So people build and they let the rubbish degrade into the ocean. And what we've seen is that rubbish debris density really differs between seaward and landward sources, which is an indication that they might, that they're acting as traps and it's just stuck at the back. So that has implications on, policy or NGOs wanting to go out to clean up mangroves, and perhaps your efforts are better targeted at the landward site where rubbish has been accumulating for years. And may have a bigger impact. So rather than cleaning up what you see at the seaward side, you should go into the mangroves and pick it up from the back. And so overall, I think more studies also need to be done on what the potential effects of community assemblage might be. So does the presence of debris also affect what species are there? So I think overall, these impacts on assemblage and flora are really more impactful on mangroves trying to recover. Plastic pollution is by far not the most important, biggest threat to mangroves. They are being at threat from deforestation and climate change and other forms of pollution like heavy metal pollution. So I think those are very big concerns. But mangroves, plastic pollution being in the mangroves seems to have a potential effect on recovery rates of mangroves. Like if you're trying to regenerate a forest, if there's plastic there, that it might not be able to regenerate. So I think more research would just mean better informed policies for conserving these very important habitats. And I would just call that we just need to look around at all our mangroves and see what's already there and try and understand its potential impact so that these policies can be made to address its source. So thank you so much for watching. I want to thank the University of Hong Kong and the Swire Institute of Marine Science. So they funded my 2 years of research, and my supervisor Stefano Kenichi was really instrumental in helping me, and also all my lab mates. So every ecologist, every environmental researcher has so many people to thank because they have a lot of friends who are helping them do this research. So I couldn't have done it without my lab mates and my friends who came out to help me. And if you have any questions, please feel free to email me or message me on Twitter or Instagram. I check all of them. I'm very interested in this research, and I'm happy to discuss if you're looking to do your own research project in plastic pollution in mangroves. Definitely hit me up. I'm always happy to talk about it. And again, thank you for watching.